So part 3 should fold and make a little booklet. It's just because the images are big, so don't think it's a lot. Comparing rates of change and understanding linear relationships. So the key concept here is that the rate of change tells us how quickly one quantity changes in relation to another quantity. That's the overall thing, is that I am comparing. It is a comparison, okay? We can find different rates of change along intervals and then compare and make decisions based on those intervals, all right? That is the real world situation. So up here, we have an example of a car that is driving. It's gone miles per hour. How do I know it's miles per hour? Because my rate of change is my y per my x, right? And for this problem, my y is my miles and my x is my time. Okay? So what I would like for you all to do is you're going to calculate the rate of change on the following intervals, okay? I'm going to do the first one just to make sure you understand what I mean. So we have 3 intervals that we're calculating. I'm going to calculate from 0 to 2. That's my interval. And then your intervals are going to be 2, pretend that I went over that, 2 to 4, and then 4 to 6. And then we're going to talk about what do we notice about these intervals, okay? So again, when I'm calculating the rate of change, that is my change in my y over the change in my x, right? So if I'm from 0 to 2, I'm going up, that's 20 and 40, right? Okay, yes. 20, 40, 60, and then I'm going over 1, 2. So I went, my change in my y is 60. My change in my x is 2. So therefore, on this time window, how fast was I driving? 30 miles per hour. Okay? So can I give y'all 60 seconds and you find the other 2? Fair enough? All right. All right. Who would like to tell me? What did you get for your change in your y for 2 to 4? What was your change in your y? The numerator, what's your numerator value? Numerator. Somebody, anybody? I don't know. I put 40 over 2. There we go. 40. That's the numerator because that's how much my y changed, right? And then my x changed by 2, like Jules told us. And then 40 over 2 gives us 20 miles per hour, right? All right, let's try it again. From 4 to 6. So our change in our y over our change in x equal, we only went 20 and we still went 2 hours. So now we've been driving 10 miles per hour, probably stuck in traffic, you know? Okay. All right, let's do another one. This one completely by yourself. So you're going to find all 4 intervals, and then you're going to answer the questions about the 4 intervals. So you're going to find all 4 intervals, and then it's asking you to compare the rates of change between the different intervals. Which interval had the fastest rate of change? Which interval had the slowest rate of change? And what might explain this difference? So what we're measuring here is the temperature over the day. Remember how we talked about that in our other part of our notes? What did we say happens to temperature? It fluctuates, right? In the morning, it's moving at a certain rate. And by midday and the end of the day, it's moving at another rate, okay? So take a moment and go. All right, so let's talk about it. For 6 through 10. So for 6 through 10, when we are looking for our rate of change, what did you guys get as your rate of change? Okay, so you estimated your values, right? So you used the 6, and 65, right? And then you went up to 10, and I would call it 75. Did you give it a decimal? You did? Okay. I respect that. It's a little more accurate. I wouldn't have been mad if you said 75 though. All right, so you said 10 and what? Did you say 75? You said 74? So the interval they gave you was from 6 to 10. So that means that you're using from 6 to 10. So you're analyzing what's happening from here to here. So these are not points. This is your interval. So this is your interval of change. Yeah, 6 through 10 is your interval. So your interval is telling you where you're going on the x-axis. So on my x-axis, I'm going from 6 to 10, and I'm measuring from 6 to 10. What is this piece of the line doing? This is what we're here for. It's okay. Okay, so from here to here, I would probably just stick to 75 for ease of calculating. So I went from 65 to 75, which is a change in my y of 10. And then I went from 6 to 10, which is a change in my y of 4, right? So my rate of change here would be, is it 2 and 5 halves, right? 2.5? 2.5. Mm-hmm. And then what are my units? So my x's are hours, my y's are degrees Fahrenheit, right? So it's 2.5 degrees Fahrenheit per hour is what I'm increasing by. And I know it's an increase because it is positive, right? And it's going up. All right, the next interval it's set to analyze is from 10 to 12. So you're starting at 10, and we said 10's right here, and then we're going up to 12. So we're analyzing from 10 to 12. So from 10 to 12, you're measuring what is the change in the y over the change in your x. So I'm going from 75 to 80. So the change in my y is 5. And I went from 10 to 12, which is 2. And again, that makes my rate of change also 2.5 degrees Fahrenheit per hour. So every 2.5 hours, 2.5 degrees, every hour, my temperature is increasing on average by 2.5 degrees, right? On that interval. All right, the next interval it said to look for is from 12 to 15. So we're at 12, still right here. And now we're going over to 15, which is right in the middle here. So from 12 to 15, how much did I go? I went from 80 to like 80. I'm going to call it 80. We want 83. I would say 83. 15. We're going to make this 83. So our rate of change would equal 3. Change in my y is 3. And I went from 12 to 15, which puts me at 3. So my rate of change is simply 1 degree Fahrenheit per hour. And then the last interval that it wants to go to is from 15 to 18. So from 15 to 18, I'm going from 83 down to 75. Remember, it's the changing your y first, right? So how do I go from 83 down to 75? I'm subtracting what? 83 minus 75 is 8. There we go. I want us all to say it after usual. That's why I give a pause. Okay. And then we went from 15 to 18, which puts us at 3. So this one is not a pretty number, right? So it's negative. I'm just going to put 2.7. How about that? Degrees Fahrenheit per minute. Okay. So with that, at your table, you should be able to talk about the think, pair, share. What did you put? Which interval had the fastest rate of change? When you're telling me the interval, we're using the brackets and saying from here to here had the fastest rate of change. Does that make sense? You also can write it using inequalities if that makes you feel better, which is the less than or equal to symbols. But you're saying where was it the fastest? Where did the change happen the slowest? And what might explain why these changes are happening, right? That's getting you to think about, like, what did you learn in science about, what causes us to be cold and what causes us to be hot? If you don't know, my 5-year-old can come teach a lesson on it for you. Okay. All right. So these are ultimate takeaways for 1B.8. Okay. Our rate of change represents how quickly one quantity changes relatively to another quantity. Okay. That's going to always be our change in our Y over our change in our X. And change just means we are subtracting, right? This is our delta and we are subtracting, correct? I'm telling you, I cannot write anymore. It's tragic. Okay. In linear relationships, rate of change equals slope. So I'll remember your rate of change, if it's a linear, it's automatically going to be your slope. Okay. For different intervals, however, you have to find there may be different rates of change. So make sure you find the rate of change for each interval. Positive rates of if it's a positive rate, that means that I'm increasing. If it's a negative rate, that means I'm decreasing. And units are important. When we have our units, remember, when we're describing the units, it is our Y per our X.